Alright, we're going to take a quick historical look at some different number systems and how they were written. And you should, when looking at these systems and playing with them, notice some things that happen. One, notice the absence of the number 0. Again, the idea of having a number 0 is kind of unique to the Mayan and the in Hindi Arabic, or the Indian Aryan numbers. And 0 has a positional place that these other systems don't have. So if we start here and look at the Egyptian system, and in the Egyptian system we've got we have characters that represent a value, and we add up the characters. And so notice each character kind of does the same thing as a place value did in our system, in the Hindu Arabic system. So if I want to write a number, I multiply by the character. And so I have 1,020,000, because I have 2 of these, 34. So 1,020,034. You have to keep track of how many of your characters. And so place is the place value. We normally think of the place value is in the symbol, and then the number of them we have is the multiplying effect, which means that numbers, the size of the number and the position of the number doesn't hold value. It's the value is in the character and how often the character is repeated. And so we could go from 1,752 as an Egyptian number, so we have to break it down into thousands, hundreds, tenths, and ones. And so there's 1,000th, so we get a lotus. There are 7 hundredths, or 7 spirals, 5 tens, or 5 heel bones, and 2 ones, or 2 staffs. Now the Roman numeral system was another system where the value was in the character. There is a beginning of a positional system here. Again, we don't have a 0, so we don't have place values, so we have to have positional values as a way of talking about some multipliers. And in the Roman system, 5 seems to hold more value, 1 hand's worth. Now what happens in the Roman system is if I'm increasing in value, I add them. But if my symbol decreases in value, I have to subtract. But there are only certain things that can proceed. And again, it's the pattern of 5s. The number 1 can come before 5 or 10. And so 1 before 5 is 4, and 1 before 10 is 9. 10 can come before 50 and 100. 10 before 50 is 40, and 10 before 100 is 90. And 100 can come before 500 or 1,000. 1 before 500 is 400, and 1 before 1,000 is 900. And so this lets us write numbers without overly repeating. So let's look at a Roman numeral. Here, C is bigger than L, L is bigger than X, X is bigger than V, and the ones are of the same value. So I don't have to do any subtractions, and so this is 100 plus 50 plus 10 plus 5 plus 1, 1, or 167. Now here, 1,000 is bigger than 100, but that's a less than 1,000. So this 100 less than 1,000 gives me 900. So that's 1,996, because of these preceding values that pull back on the larger value. In the Chinese system, again, notice no zeros, but we have place values here. And so Chinese write vertically, and they multiply. And so if we were to write in the Chinese system, we would write 3,264 vertically with 3 times 1,000 plus 2 times 200 plus 6 times 10 plus 4. And this comes close to having a place value, as the place values are listed as multipliers. And the Greeks do a similar thing. Now, we've already discussed where the Greeks didn't believe in 0, and so they used their alphabet with a couple extra added values. Vau, Koph, and Sampai are not in the regular Greek alphabet. And so each character in the alphabet has a numerical value, and then you additively can keep track of everything. But because there's no 0, you need to have the value. So going up to higher values, you would need new character representations, or you would add a large quantity of smaller values. And so we can look at the Greek system, where psi, lambda, delta, with psi being 700, lambda being 30, and delta being 4, we get 734. Appreciate the utility of the invention of our system, and specifically on how, just showing, let's see, MCM LX VII. So let's see, that's 1960, 1967. 1967. I'm going to add to it 312. So how do I do this in Roman numerals? I can't add positionally, so I have to take 2 plus 2, which is IV, and then I have 4, 5, and 10. I've got 20. I've got another 5, so V and VI is I9. 1, 2, I have a 50. So what is that? That's 79. Or 79. And then in 300s plus a 900, that's 200. MMCCL. But notice how I have to kind of work my way through everything. In fact, a lot of Roman addition and subtraction used counting boards. They would use boards where you would move a stone to keep track of the value, and then every time you would scroll over, you'd move another stone, and so you would collect ones until you had a fourth one. Then you'd have to put down an IV, and then you would collect X's until you had a fourth one. Then you'd have to put an L or an XL. And so the counting boards kept track of place. But in the number system we use, 9, 7, 2, carry the 1, and I'm done. The speed between the two is amazing. This system contains the ability to do the work for you in position. And that's truly the marvel of the invention. Human beings are clever. We find good tools to do things a little more quickly.